Alright my friends, Truax31 here again. I'm kind of digging this lighting I got happening today. Got sort of this light and dart thing happening. I remind myself of that Star Trek episode with Frank Gorshin in it, where everybody was half black and half white and his colors were on the opposite sides or something, so he was much inferior, so there was a big civil war going on. But anyway, Google that. You'll enjoy that very much if you're a Star Trek fan. So anyway, today I want to take this a little further, what we were talking about earlier, flow rates, and let's have a little closer look at this. Now, you've determined, you've done your heat loss, you have figured out your flow rates per room, etc. Now it's time to do your loop layout, and you locate a manifold, probably in an area such as a closet, right? Like that. Now, you will run a circuit into each room, or a loop as we call them. This room, for example, very easy, very close to the manifold. You would come in, run your loop in some sort of manner, and then you put your 0.6 gallons a minute down that loop, and that will heat that space. Same thing for the others. You might continue on, come into this room, run 0.9 gallons a minute, again, heat the space. Very simple. And you do that for each one of the rooms, okay? Now the problem in this scenario is, this is a very large area, and you are going to want more than one circuit in that room, and for another reason altogether different than what I'll get to another day. But for now, we're going to put, probably because of the size of the room, maybe 3 loops in that area. One something like this, may have another one in here, right, and a third one. However, sort of irrelevant how it's laid out at this point, but let's say for a minute that this loop is 250 feet, maybe the middle one 150 feet, and then the last one maybe 200 feet. Okay, now that number 2.4 is not a requirement for each loop, okay? That's the total for the area. So we need to split that flow up into these 3 loops. So how do you do that? Well, it's basically a percentage of total, right? So we've got 600 total feet of pipe. So we'll take this loop, which we said was 250, right? So, and it's 250 divided by the total footage of pipe, which is 600, equals 0.416. That's 41% of the flow needs to go into that loop. So times that number by the 2.4, and you will get a flow rate of 1. And that's 1 US gallon per minute for that loop, okay? We'll do the same thing for the other 2. The second one, that would be 150 divided by 600. That's 25% of the flow, obviously. Times 2.4, and you will find you need a flow rate of 0.6 US gallons per minute. Okay, and let's do the last one. 200 divided by the total feet of tubing, obviously 1/3 of the tubing, 0.33, times the total flow into that room again, and you'll find you will have a flow rate of 0.8. Add that up, and there's your 2.4 gallons for that space, okay? So, we know what we need per loop. How do you get that per loop will be the next video. And there's certainly easy ways to do that, so stay tuned again.